Hi class, in this lecture we want to move into section 1.3 and talk about average rates of change. So this concept of a rate of change, or you'll see in a second the slope of a line, is going to be a common thread that we talk about a lot in the coming weeks. Okay, so first off, let's get the definition out of the way. So the average rate of change of y with respect to x, as x changes from x1 to x2, is the ratio of the change in output to the change in input. Okay, so basically what this is here, you can see it's the change in y over the change in x. You might have also seen this as delta y over delta x. Well, what exactly is this? This is just the slope, right? This is just the slope formula. So what we're saying here is that we're going to consider the slope formula the average rate of change of the y variable with respect to x. So if we expand on this with the function notation, so if we look at the graph of the function, okay, instead of using y2 and y1, we see that our average rate of change here is given by f of x2 minus f of x1 divided by x2 minus x1, which is both the average rate of change and the slope of the line, okay, from this initial point here, P, to this point up here, Q, okay? I've also talked about this in the first video of the class that we've ever talked about, okay? This straight line through the graph here between 2 points is what we call the secant line. And what this secant line represents, okay, the slope of this secant line represents, the slope is the average rate of change of our function y is equal to f of x from P to Q. So it's the average rate of change to go from here to here. All right, so let's consider this function, a real simple parabola. So y is equal to f of x, which is equal to x squared. And here's what I want to do. I'm going to give you some different intervals, okay? And I want to find the average rate of change and talk about it. Okay, so the first one is I want to find the average rate of change of x squared as x goes from 1 to 3, as x just goes from 1 to 2, and then as x goes from 2 to 3. So notice how this first interval goes from 1 to 3. The second one is the first half of it from 1 to 2, and then the third one is from 2 to 3. Okay, so all it is the slope formula here, right? It's the change in the y variables over the change in the x variables. So look, when x is equal to 1 and when x is equal to 3, okay, you can find the y values by just taking these x's and plugging it in to the function, right? So when you take 1 into here, you get 1 squared. When you take 3 into here, you get 3 squared. And remember, the average rate of change is just equal to f of x2 minus f of x1 over x2 minus x1. So this is f of x2, which is 9, minus f of x1, which is 1, divided by the change in x. Well, this first one is going from 1 to 3, so it's 3 minus 1. So you can see here that the average rate of change of this function from 1 to 3 is 4. Okay, now what happens when we look at subintervals from 1 to 2 and then from 2 to 3? Will we have the same average rate of change? I don't know. Let's investigate. So when you look at the first interval as x goes from 1 to 2, and then as the second interval as x goes from 2 to 3, you're going to see something. I'm not going to go through it in much detail because the math here is real easy. But you can see here that the average rate of change from x is equal from 1 to 2 is 3. But then when you look at it from 2 to 3, the average rate of change is 5. So what we're hinting at here is when you look at equal intervals on a graph that isn't a linear graph, so this is like an x squared, a parabola, the average rate of change is not the same. Okay, so what this means here when I'm hinting at this then is if you were to look at this graph of x squared here, the rate of change, the slope, is not constant. It's always changing. Okay, that's interesting, and that's gonna come up a lot more in our advanced study. So keep that in the back of your mind. All right, so now we're going to talk about something called the difference quotient. So the average rate of change of f f with respect to x is also called the difference quotient. And it's just given by this, okay? It's f of x plus h minus f of x divided by h. So really what we're doing is we're replacing the x2 minus x1, that delta x, with just the variable h. So all that is the difference quotient is equal to the slope of the secant line from this point, x f of x, so this point right here, all the way to x plus h and f of x plus h. So all h is equal to, it's just the change in x. Okay, so that's the incremental change in x. All right, that's all it is. So it's just another way of finding the average rate of change, or the slope of the secant line between 2 points on any graph. All right, so let's do this one. Let's investigate this. So going back for f of x is equal to x squared, let's find the difference quotient. So just remember the difference quotient is f of x plus h minus f of x all over h. That's the difference quotient. So I'm just copying it from right here. All right. All right, when x is equal to 5 and h, so that delta x is 3. And then we'll do it when x is equal to 5, but then the delta x is smaller. It's just 0.1. Okay, so substitute this in, right? So we know what x is, we know what h is. So it's really just plugging in 5 for x and 3 for h. Okay, so there's my 5. And wherever I see an h, I'm just going to plug in 3. Well, 5 plus 3 gives me 8. F of 5, so 5 stays, and h is 3. Well, it's just x squared. So it's 8 squared minus 5 squared over 3, which is 64 minus 25 over 3, which is 39 over 3, which simplifies to 13. Okay, so really what's going on here, another way of seeing this is the average rate of change from x is equal to 5, really to x plus h, so for all the way to x is equal to 8. Whereas this one here, the second one we do, is going to be the average rate of change from x is equal to 5 to x is equal to really 5.1. Okay, because that's what the delta x is, the difference, the change in x. So when you substitute this in, it's the same thing. The math is just a little bit, you would need a calculator probably to help you on this one here. And you can see here that the average rate of change here is equal to 10.1. Okay, so notice not constant rate of change here, okay, depending on what your delta x is. All right, let's do this one here. All right, and I have it written out here, but I'm going to walk you through it. For the function f of x is equal to x cubed, let's find a simplified form of the difference quotient. Okay, so what you're doing here is, and this will come up on your homework as well, you're leaving the x and the h in the formula. Okay, you're not replacing them with numbers. Okay. All right, so we're going to start with our difference quotient. It's f of x plus h. Okay, so your input here, okay, you're going to take your input and you're going to cube it. Well, I'm putting in x plus h cubed minus my f of x. Well, my f of x is just x cubed, and it's always divided by h. Okay, so this right here will expand out to this. Okay, all right, you can just grab a formula, like what is x plus whatever cubed, a plus b cubed, what does it become? And you'll see that it is this. Minus your f of x, so you have this minus x cubed. Now what you're going to notice when you go to simplify this, you notice how you have an x cubed and a minus x cubed? They're literally going to cancel each other out. So you're left with 3x squared h plus 3xh squared plus h cubed. Well, this you can factor out an h. Okay, that's where this comes in here. And then what you're going to notice, which is even great, is don't forget you have this h in the denominator, and it cancels right out. Okay, and this is the simplified difference quotient. Okay, so basically what's going on here is you have a general formula for the difference quotient for this function f of x is equal to x cubed. So now I can use this difference quotient anytime. Okay, you can just give me the x and the h. No matter what the x and h is, it will always just be this formula here. All right, let's do one more. And there's no slides on this one, so I'm going to write this out so you can see this, okay? So for this function, f of x is equal to 3 over x, find a simplified form of the difference quotient. So just a simplified form. So the difference quotient is f of x plus h minus f of x over h. Okay, so now the first thing I have to do is I have to take x plus h and plug it into this. So this is 3 over x plus h minus f of x. So minus 3 over x divided by h. Okay, so now what you're going to want to do is you're going to have to clean this up. So what you're going to do is you're going to combine the numerator here. Okay, so you're going to need common denominator. So if it helps to see it, the LCD is just x times x plus h. So this is missing an x, so this becomes 3x over x times x plus h minus, this has an x, so it's 3 times x plus h over x times x plus h all over h. Gosh, now what you have to do is you have to clean this up. So I'm going to move it over here. So this is 3x minus, so minus 3 times x, so minus 3x, minus 3 times h, so minus 3h, all over x plus h divided by h. All right, well, first off, what do you notice? Look at this. 3x minus 3x. These guys cancel. So you're left with minus 3h divided by x plus h divided by h. Okay, so you can rewrite h as h over 1, and then it's keep, change, flip, right? So this is minus 3h over x plus h, change times 1 over h. And wow, look at this. Look what happens. This h and this h cancel, and you're just left with minus 3 over x plus h. And this right here, all right, is the simplified difference quotient for this function f of x is equal to 3 over x. So now you can just give me the x value and tell me the h, and I can tell you the average rate of change for that x value and for that h, which is delta x. All right, class, you'll get a chance to practice this in your homework in the coming week. And after this, we're going to move into the next section, and we're going to start talking about the derivative. So really what we're going to look at, if you remember, as kind of a preview to the first lecture of the class, is we wanted to find the tangent line at this point. So what we do is we take this point, this h, and keep making it smaller and smaller, shrinking the h. So what we're going to do is we're going to look at the limit as that h goes to 0, and that's going to give us the slope of the tangent line at this point. And it's going to be fun, and then we'll talk about something called differentiation and the derivative.